for, and now I'm being recorded, for natural gas storage and future transportation systems. And this is software that's designed to be run on your laptop. So not at supercomputers with teraflops or whatever of data, but instead something that you can run in just a couple minutes on whatever computer that you're using. And this is really for utilities and regulators currently, but I think because of the way that we're building the tool, this could be extended to any number of infrastructures and any other users. Anyone who wants to run risk quickly, we're building the system for you to be able to do that pretty easily. And I'm just going to get going. So John Bray is the PI on this, but he was unavailable today. So I'm giving the presentation for him. So within the seismic risk methodology, these are some of the items that we have been incorporating into OpenSRA. From the demand side, it deals with ground motion, landslides, and liquefaction. We also handle fault rupture, both at the surface and at depth. And then we have a number of different capacity elements from gas storage and transmission and distribution systems, including right now we're modeling McDonald Island and Honor Rancho gas storage facilities pretty in depth. We also have a couple validations for pipelines within California. And the infrastructure as well includes just sort of generic fragilities that you can use at any location that are dependent on some of the inputs of your systems. So all of these components get combined into component and system fragilities, and that's what gets put into OpenSRA. So there's a whole bunch of research that's been happening over the last 2.5 years to develop the fragility curves that then get interacted with within the program. So for the project teams, I apologize for those online. This might be kind of small. This is both a CEC and a peer-supported project. We're working with folks from UC Berkeley, from LBNL, from UNR, from UC San Diego, my company Slate, from Sim Center, Dr. Tom O'Rourke, as well as LCI. It's somewhere around 30 people that we're working with on an extremely regular basis right now. I get to project manage everyone, which means I am mostly just herding cats constantly and sending emails like, you owe me this, you owe me that, where is this? But it's been, over the course of the project, we've developed a really strong team, and I really appreciate that we get a lot of feedback from all of the developers at all times, even if David is answering a call on his phone accidentally right now. He's very good in meetings. So on the hazard side, we have John Bray, Tom O'Rourke, and some folks from LCI working on liquefaction, landsliding, and fault displacement hazard. On the system fragility side, we have John Bray looking at, and his grad students, of course. I'm assuming because we're all peer people, we know that when you list the professor, you actually know that the grad students are the ones doing the work. So fragility of buried pipelines is John Bray and his grad students. For wells and cap rocks at some of the gas storage facilities, we have LBNL. And for the above ground systems and components, we have David McCallan as well as Tara Hutchinson working on those. We also have a few other components in the system. We are trying to incorporate monitoring technologies where possible. So we have Kenichi Soga advising us on those aspects. OpenSRA development is being handled by Sim Center. Frank McKenna's back in the back there. He's been excellent at helping us to guide the software and using some of the tools that Sim Center already had, building upon those capabilities to create OpenSRA. And then Slate, we're doing the back-end analyses. We're also using some work from Norm Abramson to build efficient risk calculations, so incorporating polynomial chaos we're applying the USERF3 seismic source characterization, but using polynomial chaos to speed up the calculations all along the way. So as I said, Slate is in charge of project management, and we also have a peer center helping us with outreach, with the website, with a workshop that's coming up in January. It's really a really large number of people that are involved on the project. Okay, So where we are in terms of this project is very, very close to the end, which I'm excited about. We started off by performing some sensitivity analyses to determine where we should really guide our research. So what was going to have the biggest impact in the risk calculations at the end. So we all have our favorite things to do research on, but we wanted to make sure that the California Energy Commission was getting the biggest bang for the buck. So we did some sensitivity evaluations to figure out what we should really be focusing on, not just what our favorite things to focus on are. We then started right away with OpenSRA development. We've been working with SimCenter from the very beginning, developing a graphical user interface, and we have a technical advisory committee that's composed of folks from SoCalGas, PG&E, who else? California Energy Commission and other utilities and regulators within the state. They've been not only looking at the code as it's been in development, but talking to us through our research. We've had research tasks. You'll see 4A through F on here. Those are the main research tasks that have been happening over the last 2 years. So work on fault displacement, regional liquefaction and ground deformation, seismic response of wells and cap rocks, pipelines and gas storage facilities, sensor and monitoring technologies, and then what we call the system-wide response and fragility model, which is really just pulling all of that information together so that we can put it into OpenSRA. Most of these items on here are complete, and the reports that we submitted to the CEC can actually be found at the OpenSRA website, which is down at the bottom there. There will be peer reports that come out later because the CEC reports, as I understand it, are very hard to get from the CEC website. So we're trying to make them available. And then we know really that the peer reports will be picked up and read by many more folks than the CEC reports. So those will be coming out probably, because we have so many coming out, probably early next year, because we're going to just inundate Amarnath and the rest of the staff with, I think we have 15 reports, something like that. So it's going to take a while for all of them to get reviewed. The things that are still in draft are, because we're about a month and a half away from finishing up the code. So we're finishing validation right now and finishing compiling all the fragility models together as we're putting it into OpenSRA. So we anticipate that by the end of October, we'll have what I'll call our final executable that users will be able to pick up. And I'll say, because you guys are researchers, if you want to shoot me an email and be a test subject to see if our quote unquote final executable works, we've used everybody at my company, all of my friends and colleagues at this point to give these things a test. So we need more folks who've never seen it before. So if you want to take a look at it, please send me an email and you can help out on the project. Yeah, and then in January of early next year, we're having a user workshop, which is less about the research and more just how do you actually run this application. So we're inviting utilities, regulators, researchers to come in. It's going to be up at UC Berkeley. I think we've secured the computer lab. Is that right, Amarnath? Yeah. Okay, we're in the process of securing the computer lab so that we can actually have hands-on trials of the software. Okay, so there's a huge amount of research that's gone into this. I just want to highlight a couple little examples here from some of the subtasks that have finished up their results recently. There's obviously so much more and so many more details. You can find all those reports on the website and upcoming peer reports. But just to give you a flavor for what the groups have done. So this is task 4B. This is John Bray's group. Reverse. We have landsliding capabilities as well as lateral spreads. They've been doing modeling of all of these different cases. And then for each of those, they come up with what we're calling a damage model. So this gets you from the parameters associated with the geohazard, like I have a landslide, it's this wide, there's this much movement. And then you input a little bit of information about your pipeline. This is for the strike slip compression case. So for this, let's see. For this one, we're just inputting the outside pipe diameter and then your pipeline anchorage length. So, over what length of pipeline can it actually deform when you have the strike slip earthquake going through it. And then it gives you a mean and a standard deviation and epistemic uncertainty on the strain in that component. So I'm not going to show you all these different models. They're all in the reports and available there if you want to look at them. So those damage models then get combined with what we're calling fragility models. So these give you pipe strain. You input the pipe strain and it gives you probability of leak or probability of failure. And for pipelines, we have this broken up into tension and compression because the two systems, because the pipeline responds very differently in tension and compression. So here in blue, this is the probability of leaks as a function of pipe strain, where we're also including epistemic uncertainty. So we have the 10th and the 90th percentile fragility curves on there as well. And then over here in red is the probability of rupture or just really failure of that pipeline. If you then look at the compressive state, this then becomes a function of the diameter of your pipeline divided by the thickness of the pipeline. So here we've just sampled a couple of those parameters. So all of these get combined within OpenSRA. And if you don't want to look at these, you don't have to. You can just input the few bits of information about your pipeline and then hit run, and all of this will happen for you. For task 4C, this is LBNL led up by Johnny Rutquist. This is the modeling by Tsubasa Sasaki. So he's looking at wells with fault shearing through them. And this is his beautiful model in FLAC 3D over here on the left. Again, we're splitting up the fragility curves into what we're calling a damage and a fragility. So one gets you to your engineering demand parameter, and then the next one, in the peer parlance, gets you to your, I'm forgetting what the next one is, engineering demand parameter to decision variable. So here, this is for one of the many modes associated with wells, where it is cemented in place. They're not all cemented in place. I've learned a lot about natural gas storage facilities over the last few years. I'm an engineering seismologist by training. This was not my wheelhouse, but I'm picking it up. So in this case, the user would only need to input information, let's see, about the Young's modulus of the rock, if you know anything about that. And then the rest is just a function of the inputs from the fault displacement that's occurring. And then again, similarly, Tsubasa took information from existing failures as well as information about the strengths of wells to create probability of failure functions as a function of the shear strain within the wells for both the casing and the tubing. Because there's a couple of different failure modes that wells can have. I'm going to let you go to the reports for details on that. Task 4D is surface facilities at natural gas storage facilities, excuse me. So this is Tara Hutchinson and David McCallan. This is just one example of something that they modeled where this is a wellhead. This is what it looks like in real life. And then this is what it looks like in open seas. For these, the damage model for this specific case, I should say, P2T, you need the height of the well tree, the length of a couple of the segments in your wellhead, and then that's all the information you need. The rest is provided by OpenSRA. It's dependent on the peak ground acceleration. That might be it for this one, peak ground acceleration of the ground motion. And then that gets combined similarly with before, with a probability of failure as a function of strain relationship. So all of that goes into OpenSRA. OpenSRA, we've built it to be as flexible as possible. You can input your own fragility curves. You can input your own damage models. You can upload shake maps if you would like. You can also input your own faults. You can put that in there if you'd like. You can tweak any of the parameters in there dependent on the type of information that you have at your site and the types of things that you want to test. Because we've built it so that you could input your own fragility curves, those fragility curves don't have to be for natural gas infrastructure. They could be for anything. All it cares about is OpenSRA will give you, right now, it's just PGA and PGV because that was what the fragility curves needed, but we can tweak that so that it can provide you with any ground motion parameter. So it provides you with those, it gives you the magnitude, it gives you the distance, it gives you displacement on your fault. It's tracking a whole bunch of different geohazard parameters. And then for your fragility curve, whatever you input, as long as you're giving it a column of data and site locations, it can calculate things for you. So right now, even though it's called, even though we say it's for natural gas infrastructure, you could hijack this to do whatever you wanted. And that's really the benefit here and why I'm hoping to talk to you guys, because I know maybe no one in this room is working on natural gas infrastructure, but I'm telling you, we have a tool where you can run risk for thousands of facilities in California in minutes, not days and days and days. So you can use this for a lot of different applications. And it's going to be available on GitHub. It's up there now, but we have it still secured because we're fixing last little tweaks and things like that. But starting in January, anybody should be able to pick this up and add their own fragility curves, add other applications, anything you wanted to do. So that's it. I'm available for questions, though don't ask me too many detailed questions. For that, you'll have to go to each of the research groups. And please join us in January for our user workshop so that you can learn how to run the program. And always please reach out to myself, John Bray, or anybody on the team if you want to pick this up in the future and add your own infrastructure. Thank you.